What's up, guys? Welcome to another episode of CCT. Today I'm going to be doing the fourth day of the 30-day Leetcode challenge, and I just wanted to record myself. So the question is move zeros, and I haven't read this, or I don't think I've ever done this before, but given an array of nums, write a function to move all zeros to the end while maintaining the relative order of the non-zero elements. Okay. So you're basically just moving these zeros over to the end, and then these ones, the non-zeros, go to the front. Okay, so the first thing that I'm thinking of is some kind of pointers on, I'm thinking of 3 pointers. Okay, I definitely want a pointer at the end. That's like kind of the place where 0 should be. Yeah, I want a pointer starting off at the end, and then it's going to move left as it fills up with zeros. And if I just have one pointer on the left side, then if it's 0, I would swap it with that, move that one over, swap it. If it's 0, but I need to maintain the relative order, so it's almost like, okay. Okay, I definitely want a left pointer, and this is going to be the one that's kind of standing still and moving to the right one at a time. And then I need like an explorer pointer who's going to find non-zero elements, and then once it gets a non-zero element, but that wouldn't work exactly either, because if you had like would it? Okay, so if you had 1, there's 0, 1, that could move the 1 over here and the 0 here, but right, if you had like 1, 0, 2, oh yeah, but we wouldn't leave it that way. It's not like we would ever be swapping the 0 and the 3, because we need to move this 0 over. Okay, I mean, now one thing that I'm thinking of is like a bubble sort idea where the zeros just go to the top. I don't think that would be fast enough. That would be n squared times complexity if we did like kind of a bubble sort for all the zeros, where the zeros went all the way up. Okay, yeah, so we could do bubble sort, but let's continue with this idea of the swapping. So we have like 1, and then our like left pointer moves over, and then we get to a 2. So then I was thinking of like swapping these, and then you get to a 3. Okay, I see how this is similar to bubble sort, but what I'm saying is that, okay, so our pointer is right here now. What if you had like a lot of zeros? So instead of bubble sorting, our other pointer is going to be moving on like there. It's looking for the non-zero elements. So it's not like moving or swapping all of these zeros. It's just looking for that. So then it gets to this 3, and then it swaps it with the 0. And yeah, I think this left pointer always just moves one at a time. Does it always move one at a time? It goes until it gets to the first zero element, And then the right pointer is going to keep moving. Let's just try this. And then it gets to this 4, and then it swaps the 4 and the 0. And then after it swaps, remember the left. We could call this left pointer the non-zero pointer. Or that might not be a good name. Maybe like next spot pointer. But the right, this pointer is definitely like the explorer pointer. Then it finds the 5 again, and then the 0, and then the 5, and then if we just have zeros all the way, just gonna keep going all the way to the end. Okay. So now that I think that idea will work, so we have our, and we'll just label these pointers as indices, right? So, spot to fill can start off at 0, index 0, I believe. Well, actually, we're going to want to move that to the first non-zero element. Do we have to do that? Yeah. Because if spot to fill is pointing to a number, yeah, our logic is that spot to fill is the spot to fill, and we don't want to like be swapping the number, because then that potentially will get things out of order. Okay, so spot to fill, and then do I want to do 4 or no? I feel like we're gonna need this I for later. Or no, okay, wait, what am I doing? While nums at spot to fill equals 0, does not equal 0, sorry. Spot to fill plus equals 1. Okay. Yeah, interesting. I just thought of something. This logic might have to be repeated multiple times. Okay, I'm just gonna keep writing something, but I think this is gonna be in a while true loop or something. So, while spot to fill doesn't equal 0 spot, okay, let's just say length of nums is strictly greater than spot to fill, and C++. Okay, then what we want to do is so spot to fill is that, and then so what we're actually looking for the first non-zero element after spot to fill. So let's set explorer to start off at spot to fill, and then it has a similar loop like this, but the explorer, wow, that's less, well, explorer is less than that. And Yep. Okay. Okay. I see. I see. So, after we found this, now what we want to do is, so Explorer is now pointing to something that equals 0. Oh, wait. I had these flipped. Explorer is pointing to something that doesn't equal 0, and spot to fill must equal 0. So, now that we found those two, what we want to do is swap them. So, in order to swap in a cool way, you could do num spot to fill, comma, num explorer equals num explorer, comma, num spot to fill. And what happens is, like, these R values are evaluated first in Python, and then the explorer value is assigned to here. And then by that time, num spot to fill it's already had its R value been evaluated. So that just goes into num explorer. And it's not affected by this place in memory being changed by the num explorer. Okay, so we have swapped them, and I believe now that we've swapped them, that means there's a 0 in where the explorer is pointing to, and a non-zero where that is pointing to. I'm almost gonna say that. Okay, I don't want the Explorer to start off at spot to fill every time, because Explorer could have made a lot of progress on the zeros. So what we can do is we could just set it to being the max of the spot to fill and the Explorer. Really, the only time spot to fill will be greater than it is at the beginning. And then, like I was kind of saying before, I believe this should be in a while true loop. And then the question is when to return, not even break. Because, yeah. Okay, so let's think about this. So they're both starting off here. Let's actually, now let's just think about this. So, yeah, while that is there. So this is, wait, no, I'm stupid. While it does not equal that, yeah, while it does not equal a number, keep going. Because, wait, while it does not equal 0, yeah, so this spot to fill will be pointing to 0 at this point. Okay, so what happens if it's all just numbers? So that means it gets through the entire way. So then what we would do is I'm trying to think if I want to put this check within the while loop. Yeah, I kind of like that. I feel like that's cleaner, actually. So then, like, if the question is if the length of nums, but it could already be that at this. It's just safer to do that in case it's empty. Okay, so if spot to fill is if it's greater than or equal to the length of nums somehow, then let's, or not somehow, but like it could be equal to, but I don't think it could be greater than or equal to, but just to be safe, then we can return there. Yeah, because you've made it all the way past. And then same goes here. If explorer is greater than or equal to the length of nums, then we can also return here. Yeah, I'm just kind of thinking about this idea. So the explorer already crossed a path of like all zeros. There's no point of it starting back up where the spot to fill was. Yeah. Okay, so the explorer at this time, like when it gets out of this loop, will be pointing to a number, and then because then it gets pointed to by a 0, then in the next loop, it's just gonna continue because the explorer equals 0. Okay, let's try this out. What line? Num is not defined. Nums spot to fill. There it is. Okay. Okay, that's pretty good. Let's run. So something that I think is a really good skill to practice is like test cases. I think a lot of companies are looking for that. So, I mean, a clear test case is what happens when it's all zeros. Are we good? Nice. What about like 1 all the way over here? I was just gonna look. Great. And next is all numbers. Is this gonna work? Okay. And what about, ooh, okay. One number. A 0. And I don't know if this is acceptable. Okay, great. Seems pretty thorough to me, honestly, just at a quick glance. So let's submit this. See if it works. Okay, great. Great. Yeah, so kind of to summarize the thought process that went into this from the beginning, I kind of almost immediately thought about pointers and kind of swapping and somehow keeping a pointer at the start and like an explorer pointer. And then I kind of thought of bubble sort, but honestly, this pointer idea is an optimization of bubble sort because you don't have to start from the beginning and go all the way through every time. All you need to do is like both of these iterators, the explorer and the spot to fill, are only going through the array once. So this is like O of 2n or O of n instead of O of n squared. Because in O of n squared, in bubble sort, you would need to go find the 0, go to the end. Go through, find the 0, go through the end. And potentially do that many times or n times. Yeah, but this idea of having an explorer, which is just looking for the first non-zero, and then the spot to fill is looking for the first zero to fill. That idea works out pretty well, and it's good to like kind of draw that out here. All right, well, that's all I got for you today. I'll probably be hopefully doing this every day for the next 30 days. I mean, yeah, I have a little bit more time, and yeah. So I'll see you guys next time. Bye.